Welcome to academyblasting.com, your partner in helping you redefine your blasting through online training and consulting. My name's Anthony Konya, and today we'll be talking about geologic conditions that lead to blast tows. Oftentimes, following a blast, the site is mucked out, and when you go back you can find these large tows or elevated floors left after a blast. Traditionally, this will be blamed on things such as the geology or improper pattern design. In most cases, this is going to be a result of a couple things. The first off is poor explosive products. If that's been ruled out through accurate testing, then we're going to start looking at design, but design's not normally going to be the key. It will generally be the actual practices used for the drilling and loading procedures. Now, with that being said, there are conditions that can lead to blast tows forming based on geology, and so that's what we'll be going over today. The first condition that can lead to this is a hard geologic seam that's steeply dipping between the free face and boreholes. As you can see in this picture, we have a seam that is steeply dipping. It may be vertical, it may be on some type of angle or orientation, and this can be thought of as like an igneous intrusion into the rock formation. When this is in between those two black blast holes and that free face, this can cause tows, and this is going to be a tow caused by the burden. And so this is going to be something we'll see generally at the face or wherever this hard seam intersects the floor, or directly behind it still in that softer rock. But generally we're going to see that hard seam present in the toe. The next type of situation that affects the burden of the blast will be geologic structure. Now this can be jointing or bedding planes that are going to be steeply dipping between the free face and the boreholes. In this example here, we see these joints dipping back out of the face into the formation. This is going to cause tows, especially towards the front of the blast by the free face, because those areas are not getting as much explosive energy and the radial cracking may not be moving through them as well. So this is again going to be considered a burden type of geologic structure, just like the hard seams we previously talked about. The reason these are considered burden is because these are between the boreholes and the free face, or in the burden of the blast. And the way we fix these problems is by reducing our burden so we allow more explosive energy, assuming that we have proper explosives, proper design, and that we have proper SOPs for drilling and loading. Next, we're going to look at spacing. In this example here, we have a vertical geologic hard seam. Again, this is maybe an igneous intrusion, a seam that's not as bedded or jointed or broken up. And this is going to be between two boreholes. This may extend all the way through the face, or this may be in some isolated regions. And this is considered in the spacing because it's now between the boreholes. This is going to cause tows to form at that hard seam, which most of the time is going to be between those boreholes then. These tows can extend all the way to the face, or they can just be isolated in the very back of the shot. The next situation is geologic structure that's between boreholes. So this is going to be either bedding or jointing that's dipping between these boreholes. In general, we're going to see more structure here, and the structure is typically going to be well packed. If we have a lot of structure and the rock can almost be excavated without even having to blast, we're not going to see tows. But if we have a lot of structure here between these boreholes that's very hard and compacted together, we can see tows forming again between the boreholes and possibly all the way up to the face. In the situation where there's a lot of structure, these tows aren't going to be necessarily by the borehole, but right around the middle in between two boreholes in that spacing region. And when we look at these, we can see this table, which is our blast tow geology table. On the top, we have either a hard seam or bedding and jointing, and then on the side we have burden or spacing. And with this, we can now quickly identify what our geology is that's causing tow problems and how we can adjust it. The way we do this is by looking and saying, well, we have a problem in the burden. So in order to accommodate that, we need to reduce our burden. Now that's going to cause us to maybe slightly reduce our spacing to account for that reduced burden and get proper borehole interaction. The other table, the other line of this table, is the spacing. And this is going to say maybe we need to reduce our spacing here. Now, when we reduce our spacing, we're going to need to, again, possibly reduce our burden to get the full effects of fragmentation. But this is going to be a bit of a puzzle. That's going to be, what do we want more? Really good fragmentation with a spacing that's the appropriate size for the burden? Or would we rather get rid of our toes and look at an economic standpoint where maybe the fragmentation isn't as important? And in that case, we may reduce our spacing slightly, knowing the fact that we'll get slightly worse fragmentation, but keeping a better economic profile and reducing our blast toes. Now, before I finish out here, I do want to mention one other major reason that we have blast toes, and this is going to be from poor timing. Timing a blast too fast will very often lead to blast toes, as rows behind the first one are going to feel over-confined, and they're going to crater instead of radially fracture. So this is one of the major areas we'll look at when we first start looking at design if toe problems are apparent, especially towards the back of the entire pattern. Now, before you leave, one last thing I want to mention is we do have an exclusive offer right now where you can download a free guide to identifying toe problems, both from geologic settings, explosive performance issues, or from pattern design errors. So if you click on the link below, that'll take you to sign up to get that free guide. That's all for this presentation. Again, my name is Anthony Konya, and I'm with academyblasting.com. Thank you for listening. Please make sure to subscribe to our channel.